right, here's our first video for section 6.4. We've already talked about adding and subtracting rational expressions with common denominators, and we started talking about least common denominator. Now let's put them together and do adding and subtracting rational expressions that have unlike denominators. So we're going to have to first factor so that we can find that least common denominator. We need to make sure that we multiply both the numerator and denominator of each fraction by that common denominator, if there's anything missing. Make sure that when you add and subtract, remember you keep the common denominator, and then you just combine like terms from the numerator. You either add or subtract the numerators together. We're going to, once we combine all of our like terms, we're going to simplify our final answer, possibly by factoring again, but making sure our answer is in the most simplified form. All right, let's do a few basic ones real quick before we get into some of the rational expressions. Remember that when we have two fractions and they're either added or subtracted, we need to have a common denominator. So if I have 2/3 plus 3/4, before I can add these fractions together, I need them to have a common denominator. So between 3 and 4, my common denominator would be 12, right? Common factors of. And so the first fraction needs to be multiplied by top and bottom by a 4, and my second fraction needs to be multiplied, the top and the bottom of it, by 3, so that my denominators are both 12. When I do that, my first fraction turns into an 8/12, and my second fraction turns into a 9/12. Now that they have common denominators, remember I keep the common denominator and I just add or subtract the numerators. So 8/12 plus 9/12 is really 17/12. I can't reduce that anymore. There's no other common factor, so that looks like it would be my final answer. Remember, we can do the same thing with rational expressions. We just have to make sure that we have a common denominator if we're adding or subtracting those rational expressions together. So if you look at these two fractions, the first denominator is x, and my second denominator is 2, and they need to have the same factors. So in my first fraction, I need to make sure that I multiply both the top and the bottom by 2, because it's missing a 2. The second fraction, I need to multiply both the top and the bottom by an x because it's missing an x. And that way they both have a common denominator of a 2 and an x. When I do that, my first fraction turns into a 14x over 2x, and my second fraction turns into a 3x over 2x. Because I have a common denominator now, I can combine my fractions by keeping my common denominator and then just adding or subtracting my numerators. So 14x minus 3x is really 11x. Now, if you look at the numerator and denominator, don't they both have x's that are just being multiplied by, not connected with a plus or minus sign, but they're just factors of? So it looks like I'm able to reduce both the numerator and the denominator by an x. That leaves me with 11 over 2. All right, let's do some more of these. Let's look at example number 1. We want to add and subtract. So remember, as soon as we're adding and subtracting fractions, we need a common denominator. So let's first look to see what our common denominators would be. In this first one, example number 1a, you can break down the denominators into factors if you wanted to. What factors multiply to give you 8? You should get 2 times 2 times 2. And then you can figure out what factors multiply to give you 12. That should be 2 times 2 times 3. And then make sure that you multiply everybody by the common factor. So if 8 breaks down into 2 times 2 times 2, and 12 breaks down into 2 times 2 times 3, let's make sure that everybody has the same factors. In my first fraction, I have 3 2's, but I'm missing that 3. So I need to make sure that I multiply both the top and the bottom by 3. So now it has 3 2's and a 3. The second fraction has a 3, it has 2 2's, but it's missing another 2. I want to make sure that I have the same factors in the second fraction as I do the first fraction. So I'm going to multiply both the top and the bottom by 2. Really what that gives me is a common denominator of 24. My numerator now of my first fraction is a 15x squared, and the numerator of my second fraction is now a 14x after I multiply the first one by 3 and the second one by 2. Now that I have a common denominator of 24, I can simply combine these fractions by keeping my common denominator and just adding my numerators together. So I have a 15x squared plus 14x. Now those aren't quite like terms, so I can't combine them, but I can look for a GCF possibly. Looking at my numerator, is there a GCF that I can factor out? You could take out an x, leaving you with a 15x plus 14, and my denominator stays at 24. And it doesn't look like there's a common factor from the numerator and the denominator, so it doesn't look like I can reduce this anymore. All right, let's look at another one. This one looks a little bit different because now we have some variables in our denominators. Remember when I had the 12 and the 8 from my first problem, remember I needed to multiply this by a factor of 3, and I needed to multiply this by a factor of 2. But look what else is in my denominator. I have some x's, right? In my second fraction, I have 2 x's, an x squared. In my first fraction, I only have 1. So doesn't it need another one so that it has all the same factors as the second fraction? So I'm going to multiply the first one by a 3 and an x. So really that I have a 24x squared in my denominator. My second one I'm going to multiply by 2, top and bottom, so that it has a 24x squared in the denominator. When I do that, my first fraction turns into a 21x over 24x squared, and my second fraction turns into a negative 10 or minus 10 over 24x squared. Now that I have a common denominator, I should be able to combine them with a common denominator and then add or subtract their numerators. So I have a 21x minus 10 over 24x squared. You could look for a GCF in the numerator. It doesn't look like I have any. And so because I have 3 terms and I have no GCF for all 3 terms, remember it has to be a common factor. Since there is no common factor between all 3 terms, it doesn't look like I can reduce that answer anymore. So that would be my final answer. All right, we're going to do example number 2 in the next video.